Hello again, math students. Today is going to be a nice short lesson. We're just going to review what we've already learned now. Kind of in reverse order here, we've got spheres, cones, and cylinders. We started with the cylinders, then we went on to the cones because all we did was change the formula for the cylinders. We multiply by 1/3 or divide by 3. And then for spheres, we only have a radius, so we've got a different formula there, but still going to be very similar. So let's just put all of these formulas together today. Let's just see if you can remember all of these formulas. I want to know the formula for the area of a circle. I know it's not a volume formula, but the area of a circle comes into play quite a bit. That's going to be pi r squared for the area. Volume of a cylinder, the volume equals the area of the base times the height, but the base is a circle. So we would have pi r squared for the area of the circle times the height. The cone, same exact formula. But then we also multiply by the 1/3. And I've told you several times, I like to just divide by 3. In fact, this time I just wrote it as that divided by 3. Multiplying by 1/3, dividing by 3 is the same thing. Volume of sphere, one way that we wrote it was V equals 4/3 pi r cubed. And I also showed you this way. This is kind of more like what I do when I'm typing things in. I'll find out my radius cubed times 4, divide by 3, and then I multiply by the pi at the end. So those are all the formulas that you need. If you don't have those somewhere, if you're not comfortable with those yet, you might want to pause the video, write them down. You need these formulas. So for a cylinder, my volume formula, that's what I'm always going to start with, is pi r squared h. I'm going to put in all the stuff that I know. Now, the diameter is 10 feet. You'll notice in my formula, there is no diameter. I cannot substitute the diameter for the radius squared. The diameter is 10. The radius would be 5 feet. And when I substitute 5 in for the r, 5 squared is 25. It is not 10. They are not interchangeable. You have to make sure that you're using the radius. So my substitution, I would have pi times 5 squared times 21. This is where you're going to grab your calculator. And again, I'm not going to type in 5 squared because I know that that's just going to be 25 times 21, and then multiply that by pi. So my answer here is 1649.336, blah, blah, blah. When I'm rounding to the nearest tenth, that's this spot right here. This 3 was not big enough to make it round up, so it just stayed as a 3. 1649.3 cubic feet. Volume is always cubic for our measurements. For this cone, remember the volume formula for a cone is 1/3 pi r squared h. Or, as I showed you on the last slide, we could just have the pi r squared h all divided by 3. It's just another way to write it. This time the numbers aren't quite as nice. 5.7 is not going to be a number that I'm going to be able to do in my head when I square that. So 1/3 pi 5.7 squared, and then the height is 12. I've also mentioned I like to personally do things like cancel the 1/3 with the 12 and make that into a 4. However, if you're going to use your calculator anyway, there's really not a huge advantage to doing that unless you just remember that it's a 4 and then you only have to type that in instead of the times 12 and divide by 3. So 5.7 squared, and then we're going to multiply that times 12 and divide by 3, and then multiply by pi. This is going to give me, for my volume, it's about 408.2813. Now, this is the spot I care about. The 8 is actually big enough to round that up. So I would get 408.3 cubic centimeters. For a sphere, this time they're giving me the diameter all the way across. So the radius is going to be 15. meters. My formula, 4/3 pi r cubed. So that 15 is going to go in for the r. 4/3 pi times 15 cubed. 15 cubed is really big. 15 to the third power is 3,375. And then again, I like to go times 4, divide by 3 times pi. I get, for my volume, 14137.166, and it's just going to keep on going. But this 6 is big enough to make this round up to a 2. So we should have 14,137.2 cubic meters. Now, by the way, if you have not been using the pi key in your calculator, if you just use 3.14, especially on a number that gets this big, your answer is going to be slightly smaller than ours. It's going to seem significantly smaller on this one because the numbers just ended up being so big. But it's not that much of a difference. This problem is actually a hemisphere. Only a half of a sphere. I'm going to do this problem like a full sphere. And then we're just going to cut it in half at the end. There isn't a specific formula that I need you to know here. We would just be multiplying by 1/2 or dividing by 2. And there's different ways to write that, but I'm going to avoid that for right now. I just want to pretend this is a full sphere. Now, if you'll notice, the radius on this is 15 inches. I know it's a different label, but the fact that that's 15, and I just did a problem that had a radius of 15 means I know that I could just take my answer from C and cut it in half, right? I could take 14137.2 and divide it by 2 or multiply it by 1/2. It's all of that same work. I'm not going to make you redo all that work. Just divide it by 2 because I only have a half of a sphere, a hemisphere. So when I do that, 14137.2 divided by 2, I get 7068.6. And this would be cubic inches. So that first answer is leaving it in terms of pi. Most of my answers I didn't leave like that, but that's another option that you have there. So today, I told you, nice short lesson. There's a review volume worksheet that has all of those different shapes on it. Cylinders, cones, and spheres. After you finish it, make sure you check the answer key in Schoology. And then there's a quick learning check in Schoology when you're done. If you have any questions, let me know.